Hello, folks, and welcome to another stream. My name is Luciano, and I'm joined by Roberto,
Hello.
who just left his bed, apparently.
Yeah,
So, yeah,
it's born.
welcome to the stream. What we do in the stream, if you're new, is we try to learn Rust. We have been trying to learn Rust for a while now, so hopefully we have learned something in the process.
Or
And
not.
or maybe not. You'll probably be able to judge that throughout the stream. So we have been doing a bunch of different things from coding challenges, advent of code, building small and stupid games with Bevy. And now we started a new adventure where we are using this platform called CodeCrafters, which allows us to do coding challenges, but rather than just generic types of coding challenges, we are building software, like the software you would use every day, things like Redis, BitTorrent, Git, and stuff like that. So there are different challenges where you are guided through building a real piece of this kinds of software. And we are doing the challenge related to the BitTorrent client. We have been doing that for I think the last four streams. So this is the fifth episode, if I'm not wrong. So we
Maybe.
have
Yeah.
yeah, we have done a little bit of progress, and today hopefully we'll get into downloading a first chunk of data from a peer. So we should be getting into the nitty gritty details of the, I guess, data transfer protocol peer to peer of BitTorrent. We also have Anandir and Tommaso in the chat. Hello, guys. How are you today? Thank you for joining the stream. But yeah, I will say I'm just going to drop some links in the chat. But as I do that, should we start to share your screen, Roberto?
Yay. Yes. Let's recap where we left last time.
Mm-hmm.
Tell me when the screen is on.
Should be on. Chat,
Okay,
let us
cool.
know if it's too small.
I think it's the same size as last time, so I didn't touch this editor in the
Looks
meantime.
good to me, but yeah.
Oh, well, anyway, tell us something if it's too small. Last time we implemented the handshake command. We did a little bit of refactor to you to have a command enumeration to better handle instead of an if else if. We implemented the handshake that is starting using the TCP connection to appear to just send a BitTorrent handshake message and receive a BitTorrent handshake message, extracting the peer ID from it. That is a specific subsegment of the buffer of 68 byte that we receive. We send a buffer of 68, we receive a buffer of 68 bytes, and then the last 20 are the ID of the peer that is answering us, and we had to print it. That was our assignment for last time.
Mm-hmm.
What we have to do today? Today we have to download a piece. If you remember, that's where it was. I think was parse the torrent file. When we were parsing the torrent file, there was this info dictionary that was saying length in bytes of a single of the torrent file, name, length of the piece, and number of pieces is the SHA of all the pieces together. So here we have an idea of how many pieces we have because we know the length of a piece, so we know how many pieces this file is made of. Today we have to download one of these pieces that is defined in this dictionary here in some steps ago. Back to us. In this stage, you will download one piece and save it to the disk. In the next stage, you will combine them. Okay, let's start by in one. To download a piece, your program will need to send a peer message to appear. The overall flow looks like this. Read the torrent file and get the tracker URL. Perform the get to the tracker to get the list of peers. Establish a TCP connection with the peer and perform the handshake. And until here, we did everything. Exchange, I suppose in the same TCP connection, multiple peer messages to download the file. This is what we have to implement now. A peer message. Peer message consists of a message length prefix, 4 bytes,
Mm-hmm.
a message ID. Oh, we have the length. Yeah, we were thinking of bit fields, but we have the total length of the message. A message ID of 1 byte and the payload of variable size, but we know the variable size because
Yes.
start telling us the variable size. Here are the peer message you need to exchange once the handshake is complete. Wait for a bitfield message from the peer indicating which pieces it has. This message ID is of type 5. Here there is a page with, probably need to make it bigger, with the protocol, and down here on one point there is the list of all the messages. Yeah, for example, choke and choke, interested, not interested, FB, feed, request, peace, and kind. Those are those payload types that we have. We have to wait for this that comes from the peer to us. It's 5. We have to send an interested message. The message ID of interested, the payload is empty, so this is easy. So probably the length of this message is 1 because, or 0. Interesting. So the length of the message includes the message ID or not?
I think it does, but yeah, good question.
Worst case scenario, we get an error. Wait until you receive an unchoke message back. The message ID of for unchoke is 1. The payload for this is another empty body. Okay.
Okay.
Break the piece into blocks of 16K and send a request message for each block. Okay, so a piece is made of blocks, and we need to
Hmm.
get the blocks. The message ID for request is 6. The payload consists of, and I suppose the payload is again another be encoded message.
Yes.
So we have to create a struct that can be serialized and be encoded.
Hmm.
Index, the zero-based index of the piece. So the piece index, not the block index. Begin, the zero-based offset within the piece. Okay, this will be 0 for the first block, 2 at the power of 14 for the second block, and so on. Length, the length of the block in bytes. This will be 2 to the power of 14, 16K. The last block will contain 16K or less. You need to calculate this value using the piece length from the beginning. Wait for a piece message for each block that you have requested. The message ID for piece is 7. The payload for this message consists in an index of the piece, the begin offset in byte, and block the data for the piece, usually 16K in length,
Okay.
except the last one. After receiving the block and combining them into one piece, want to check the integrity of each piece by compare this time one, because we are downloading only one, comparing its hash with the value provided in the torrent file, and then we have to run it.
Yeah, makes sense.
To improve speed, you can constantly pipelining your request, recommending having 5 requests pending at once to avoid the delay between blocks being sent. Okay, no, I think we will start in a serial way and then send, receive, send, receive, send, receive. We can optimize these 5 pending requests at once, maybe another time. What do you
But
think?
pipelining doesn't mean multi-threading. It just means you send multiple instructions one
It
after the
means
other,
that you
right?
send the 5 requests. Here you say you have the request, no, the request type. You send 5 of them, then you wait for a piece message. One, when you receive a piece message, you save it and you can issue another request until
Hmm.
you run out of requests. You can do that probably in a multi-threaded way, or you can do that inside the sync and await block. This
But
is I
no,
also.
what I'm saying is that the concept of pipelining is on the same socket, so you're not creating multiple connection. It's
Oh no,
just
it's on the same. It's on the
yeah.
same socket. Yeah, but TCP packet can travel in unsorted order. It's not forced to be
Hmm.
predictable. They can
Basically,
write in.
you keep writing on the buffer, and then on the
Yeah,
other side, eventually, is gonna consume all the previous messages, right?
yeah. Here, maybe we can start saving to memory and then flashing all together to disk later on, because we have the size of the piece from the torrent file, so we can allocate a vector with capacity of what we need, and we can write in that one.
Hmm.
and
Sounds
then
good.
flushing all of it to the disk in the last step. What do you think?
I think so, yeah.
Okay, so it will be called with download piece dash o, the destination file, I suppose. Sample torrent is the torrent file that we have, and the piece index starting at 0 based is the index of the piece that we want. Okay, so let's start expanding our enumeration with the new command. Where is it? Okay, here. Here we have a parameter, yeah, sorry, a command with an underline. What args snake case? Rename all snake case. So I have to write like this inside.
I think it will be automatically renamed
Okay, this index.
with that flags rename all.
Hmm. Yeah. So we were saying the piece index is an integer. I use size is fine. Let me disable this guy. Snooze for 60 minutes. Thank you. But we need also to take a dash o parameter.
Mm-hmm.
How do we do this with Clapper? Do you know it out of your
Good
head?
point. I think there is a way to get flags. So let me search for it.
I can search for it in the meantime. Okay, there is an arg annotation, short long,
Yes.
and in our case, we want only one dash. Let's look again in the exercise. Yeah, one dash, so it's the short form, the one dash.
Mm-hmm.
And can I add it to the command itself?
I
This one
think
was
so. I think you just need to add it in as an annotation there.
is not name. In our case, is output.
Yeah,
That will be shortened as O.
I think so. Yes.
Yes. Now the match case down there should complain that we don't handle our download piece command with output, torrent file, and index. Okay, here we need to let's start debugging the
Exactly.
parameters.
Just to make sure everything works.
Yeah, and we send back an OK, too many round parentheses, and the semicolon is done differently. OK with lowercase k, the torrent file, and in this guy here. Okay, now if we call with this our let's say 0. What do we have? Output is a slash stamp test piece,
That's good.
torrent is sample, and piece is index. Okay, until here we are fine. Now, I think we need to refactor this handshake in a function that gives us back the stream, because after that we have to work on the stream.
Mm-hmm. Yes, good point.
Yeah. So we need to refactor that. So all of let me think, because we have to do all of this to do the handshake. But this function also needs the response buffer back from the handshake. True that we can just return directly the encoded version of it. Okay, so let's make a function out of this. Okay,
Mm-hmm.
compute info hash of the torrent file. So given the torrent file, let's take this. maybe we need also to start having functions in another file, but less time.
There is always time for refactoring.
Yeah, there's always time for refactoring. This must return. Can we return a TCP stream?
I think so.
And this is taking the torrent file as a string. Okay, yes, it's taking the torrent file as a string. It's not happy about this because we don't
Because we haven't
return
returned
it.
it yet.
Yeah. Now, like times will start to bite us. Oh, you don't need the return. You can just do this. And
You need to make
also,
this function async because you are using a wait.
oh yeah, true. Async. And also we need the peer. The peer as a peer.
Hmm.
And I have to return an error type, not a. So I have to return a result of a TCP stream or what kind of error?
Uh,
Generic error, an empty error for now, or a string empty.
but then in line 194 you need, and then 192 you need to do map error.
122. Sorry, what?
192 and 194 you'll need to map the error, whatever error is returned there, which is probably going to be like a IO type of error.
Okay. Or we have to return the same type of
If it's consistently the same, yes.
result. Tokyo TCP stream is not from residual
Oh
result.
wow.
Oh god, standard IO error.
Yeah,
Okay,
it's kind of.
we were saying
Do
map
you have
error.
anyhow in this in the crates, in the list of crates?
Yeah.
We do. Okay, so you can probably do anyhow column error there in the, rather than the unit type in the signature, lowercase. Yeah, column should be error, I think. Yeah, there you go. And now where you do map error, I think you can just do exclamation mark error. Sorry,
Yeah,
I
but
oh yeah, it's
is
already a
is
generic one.
is
Cool.
is happy. Is
It's
happy.
already
Is
implementing all
complaining.
the conversion. Cool.
Yeah, is complaining that we don't use it. But we also need the response buffer. We don't just need the stream, but we need to make, or we don't use the code here, or we don't
Mhm.
use the function here, because we need the response buffer last bit. Uh,
Right.
but we can return a tuple. What do you think with the peer ID?
Given that we are calling this function handshake, it could make sense.
So we return a tuple with the stream itself. Let me check how many parentheses I got wrong. And then here we return a tuple of this and a string and a comma. Okay, now
Sounds
we
good.
can try to use it. To use it, we can replace all of this.
You need the peer, so
Yeah.
I think you needed a little bit of that. Or not, because we did create a conversion of peer, right?
I think we just need this. Let's try. So here we do an handshake and shake. Okay, yes, with the torrent file and the peer. And the peer ID, we use it here. What's happening here is not happy because, no, it's not some, it's an okay.
Mm-hmm. Why doesn't like that?
We have to await it because it's a sync.
Oh, okay, that's fair enough.
And now,
Now, if you put the question mark, you can remove the okay.
I can remove the okay because it's throwing error, because the main is throwing error. Okay. Do you want to try if it's still working? I
I
think we
think
still
so.
have. I think I still have in. Okay, this was the handshake from the last time. Yeah, still
Yes.
working. So we refactored the handshake out of the equation. Now for our protocol, let's do everything in here for now. Then we can probably refactor in functions. This time we need the stream, but we don't care about the peer ID.
Unless we'll care later, but I don't think so, right?
Okay, we are not specifying a peer in this command
Okay,
line, so we
fair
can
enough.
chat with any peer, right?
Oh yeah, that's a good point.
Okay, but to do
Does
so,
it say if we can just pick a peer at random?
but here it say that all peer have all pieces, so it's not that we have to cycle through them and look whoever has the piece that we need. They all have
Hmm.
all, so I will take the first one and just be
Okay, yeah.
happy about it. To get that, we need to, we need to, we need to Here in our handshake, we were taking the torrent file because we were only needing the info hash. We were not needing anything else. This time we need the peers. We have the peers function. So at this point, this can be refactored again also.
Hmm.
Here, tracker response, get peers. Tracker response is the CRD of the body. The body comes
Yes.
from the unwrap. Append pair. So here is the request, so we can refactor all of this into in a get peers function.
Yes.
Okay, so async function get peers, and it only takes torrent file as a string. It gives back a result of what is a vector of peer. We have a vector of peer.
Yeah, I think that's the only thing we need, right?
This get peer gives back a vector of peer. Okay, so we give the same type back. So this is a vec of peer, comma anyhow error. You can close result. Okay. Now let's go and take the code from the peer command. The peer command is doing. I will copy. Let's do the
By the way,
request.
does it make
Body.
sense? We have a struct that represents the torrent file, right?
Yeah,
Does it
this
make
is this tracker response.
no, the torrent file itself, the one that contains all the hashes of the parts, because we will need those as well, right?
The tracker info, this one you say?
Uh, did we call it trigger info?
I think so.
Did we create one generic for the torrent file itself, like the content of the torrent file?
The content of the torrent file is this torrent info.
Okay, yeah. Should we?
Size, suggested name, then this torrent info is used inside the meta info. But meta info is just an announce, an additional string for
Mhm.
the announce server and the torrent info.
Okay, what I'm trying to say is that I think we will need the torrent info as part of what we need to do.
Mhm.
So it might be useful in our function to just pass like construct it outside the functions and then just pass it in.
Okay. So to construct the torrent info, we need to stop announce. Then the torrent tracker response is this. We have the info, so we can refactor info in get info, and this get info is getting back this decoded info
Perfect. Yeah.
message. Okay, so let's start then. Let's comment this a moment. This is not async because the info are not async. FS read is not async, right? There's nothing async here.
Don't think so.
I don't see anything async here. So function read torrent file takes a torrent file string with spec a meta info. Let's see. And here we have to return the decoded info. Now he's complaining about what? Ah, no, because I don't have to extract all of this. Push it. This was part of the original info. Okay. Okay. So we can replace this with read the torrent info of our torrent file.
Perfect.
And now our get peers function will do of the torrent file. That are those the code info here. Then this code we have to take it up to response body, let peers. Okay, I think all of this is our get peers. Here we have to say that our decoded info is equal to this guy. We need a semicolon at the end of the line. Let
Yeah, but what I'm saying, what if we pass the torrent file directly as an argument
to
to this function?
we are passing the torrent file as an argument to this function.
But the decoded one, I mean.
Ah, the decoded info you want to pass, the meta info.
Yes, so we created
Okay.
once and we have it available for the rest of the command.
Okay, meta info. I take it. Here is complaining that I'm returning the wrong stuff. Back to us. Now it's called the meta info, not the coded info.
Mm-hmm.
So get peers is taking the URL, preparing the request, taking the info hash, doing the request. Again, this is called meta info now. Taking the response, the body, taking the peers with the get peers, and this is what we need to return. So instead of assigning, we can just directly return it. No, because we have to return an okay of this. Return an okay of this. Is everybody happy?
Yes, we
Everybody
actually
is
have an
happy.
unwrap there in line 211. We can probably put a question mark now. And the same in line 209. Oh, actually, even in line 187. Now, just for the records, this is a little bit of a shortcut because anyhow doesn't type any error, as the name suggests. It's literally like, this is whatever error. I'm just gonna take it and give it to you. So you lose lots of information there that could be useful for debugging, but it's a bit of a shortcut to basically avoid to spend time designing all the possible errors.
So here instead, then what we need to do is to say that our peers are the get peers of the get read torrent file of the torrent file.
Mm-hmm.
And now he's complaining about item.
You need to await.
Oh yeah, I need to await again. Forgot again to await. Okay, so now Pierce at this point is a vector of Pierre, yes. And we refactored also Pierre out of the way. Info, yeah, we just refactored this for info, then all of this is
Mm-hmm.
formatting, so stays there. Okay, okay. Anyway, the CodeCrafter test will test all the refactor that we did.
Mm-hmm.
Okay, at this point, we need to take let meta info equal read the torrent file of our torrent file. Let peers equal to get peers of our meta info. Here we do an handshake with the first peer. There is a first.
If you do .iter .first, yes. And you also need to unwrap because there might not be a first.
If I put a question mark,
I don't know. Try.
considering awaiting, again, I forgot to await. Await.
Okay. No, I think it's just that you need to unwrap, right? Oh no, you need to do dot next. I don't think there is a first. And then unwrap. Or
Or die.
try the question mark. I never tried it. I'm not sure if it works.
It gives us a reference to a peer, iter, instead of giving us a peer, but we can change the handshake to take a
Which is
reference.
probably better, yes.
Can change handshake, and handshake is also used here, and here we just pass the reference. Torrent file value moved.
Yeah, that's another point. Maybe we should pass there maybe the meta info just to be consistent. And also we can pass a reference as well.
To the meta info. So at this point, also in our handshake, we need the meta info. Copy, paste.
And the reference.
Yeah. Oh, I forgot reference. Yes, I forgot reference. I forgot reference downstairs. No, down there is fine. Where is it? The handshake function is here. So this point is a meta info of type reference to a meta info.
Perfect. And now you can remove
And
some stuff.
oh, but then we have to refactor compute info hash because compute info hash is taking the string file, torrent file
But
as a parameter.
does it open again? If you go there, I think we.
Yeah, it's opening again. So
Oh,
we can just do this. We can just do this. Instead of using info hash, we do meta info dot info compute hash. This should be okay. And now we have our.
okay.
Now we have our info hash. Then info hash is used here as slice. Binary, yes, we use the binary version because we have to stay binary here. We don't have to use the hexadecimal, the formatted version. Okay, now should be everybody should be happy with the types. And here what is happening? Borrow of moved value meta info.
Because in line 302 we passed it rather than passing a reference.
Okay, get at this point
Yeah.
also here we need a reference.
Wait, what?
String doesn't implement copy.
Okay, do a dot clone.
Okay. Here's Here we need a reference. Anybody else unhappy? Here we need a reference. We happy everywhere else.
Looks happy.
Compute info hash is never used. Now I make it public. So no, as a complaint. Okay, let's go back to us. Now what we have stream. If this is okay, no, we are not using it. Yes, it's true. Okay, we refactored all out of the way. Now wait for a bit field message.
Mm-hmm.
So now we have to enter a loop where we receive messages.
Yes. So we can do this, I think, in two ways.
Mhm.
One very bare bone, where we literally do like a endless loop, and we try to manually create all the, I guess, all the branches of our state machine.
Mhm.
Or there is a library inside Tokyo Utils, which I don't know if it's already installed, that is called Tokyo Util Codec, which I believe should allow us to implement like a decoder. So we could say, we could define like an enum of all the possible messages that we could get. Actually, we could create an encoder and a decoder, so we could do it for both incoming and outgoing messages.
How was with capacity? I don't remember the syntax.
Um, with capacity, yeah.
I'm doing something wrong.
The U8 needs to be, I think that needs to be before the parentheses, so remove it from there. Actually, you don't even need it. I think you will be able to infer it when we start to insert data or not. Or
Or
if
we
you do it
can,
there, yes, that's
yeah,
probably easy.
okay, we can do this. From the meta info, we should have the size of info dot length of a piece, except the last one, but we over allocate the buffer to be sure.
Mm-hmm.
Mm.
Okay.
So, do you want to go the hard route of having everything mapped to types? I don't think we can do that, all of that today if we do that, but maybe in both cases we can't do everything today.
Yeah, how do we test this? Like if we want to try it step by step, even manually, now just not doing anything fancy.
Ah, well, we can receive the first message here. We can do stream
Yeah, let's try to do that.
dot read.
We have read exact, right? If we,
Yeah, we know that we have to read exactly 5 bytes. And here we can have let this is the how is called bit field. Wait for a bit field. Ah no, bit field is a variable length, but we know the length more or less. But we can over allocate for now. Bit field. We can allocate a weight of 4 bytes plus 1 plus the bit field. Let's say that we allocate 256 bytes, and
Mhm.
we hope that are enough. Then we read in our bit field what it means in the reference to the bit field. Read exact.
Probably need a mutable reference.
A mutable reference to a buffer. Can I specify the number of bytes or?
I think read exact is going to try to fill the buffer.
And if it send less bytes, what's happening?
Probably just going to hang there.
Okay, but we know the first 4 bytes. Okay, so let's do this. Let size is a U8 of 4 bytes.
Yes, and you
Now,
can definitely read exact that.
yeah, we can read exact the size. At that point, we know the size. Let current message size equal to size. Now we have to go from the vector.
Yeah, because the screen was still working. Last time we had the opposite issue. Your screen disappeared suddenly. We had like 10
Perfect.
minutes without screen. But yeah.
Perfect. So now let's take the command that we should fulfill. That was here, down here, copy, insert. So now we received a size of 2,
Okay.
payload size of 2.
I think that's expected, right?
I was expecting 1. Why 2?
What is the type 5? Let's check that.
Type payload type 5 is what we were expecting because it say that 5 is the bit field. Well, no, 2 is fine because it's 16 bits. You can ignore it, will send you something, but we can ignore it.
Okay.
We can read and ignore the payload for now. But bit field is empty, so we were not reading it really in this way. Because I created a vector with capacity. Then I tried to read into it, but it was not reading it because it should have read the 2 bytes. So I was expecting 2 bytes in this array here,
Mm-hmm.
and I don't see them.
Right.
So let me think.
Yeah, how we could do read exact? What is the size of bit field? Is it maybe 0? Is that the issue?
No, size was 2.
Okay.
Know what for a n in from 0 size. Bit field push stream read u8. But here read u8 is almost there. Let
But if you read U8, doesn't just return it? Do you need to
Oh
pass a
yeah,
buffer?
no, he's retarding it. Yes, you're right. He's not passing the buffer. Sorry, my my brain farted for a second. I mean, for underline, I don't need this number for real. So very
Okay.
ugly, eh? It's incredibly ugly, but I just want to see what we can see in that one.
Right,
So in
yes.
theory, it should push inside this all the U8. Let's try them again.
Oh, it's hanging. Is it?
Hmm.
Let's do some prints. Let's inside the for loop. Let's see how many iterations we do.
At this point, let's take our end. Do I need to format it?
If you put the n there inside the string, yeah.
Okay, but let's review. We read how many bytes we have to read. We read the payload. -1 because the payload itself is 1 byte.
Oh, right, yes.
Okay, bit field is 1 byte, 224, that in binary is whatever.
Hmm.
That's what is 224?
You can do your Python magic.
I don't remember the string, the syntax. So it means that it has this part is made of three blocks,
Hmm.
and the three blocks are all available in this peer. And it
Okay.
starts from the most significant one, not from the less significant ones. So again,
Where
this peer,
where do we know that there are only three parts?
because we only have 3 bits at one, not blocks, not parts.
Okay. But how do we know that these are all the blocks available and
Oh
not the
wait,
one?
no, no, those are the parts available.
Right.
Which pieces it has, and we know that are three because in our info, if you remember,
Yes, we have only three ashes. Yeah.
we only have 3 ashes, so it means that we only have 3
Parts
pieces,
or
parts,
pieces. Yes.
pieces, 3 something, and those this peer has all 3 of them, but we have to remember that we have to start from the left, not from the right, but the assignments say to don't care about this. Okay, so finally we arrived to have something working. We were able to read the message, to find the payload type, and then based on the payload type, we know that this was a bit field. We have to ignore it, but we have to read all the bytes anyway to advance. Uh, we could go on if you want for a while, and then we can refactor next time with this
Hmm.
horrible way of doing stuff just to get a grasp and find these edge cases. We went in,
Yes.
and then at the end of it, we can do that in the proper way, like you said, with all the proper
Yeah,
types.
creating like a protocol, an encoder
Yeah,
and a decoder type of
yes.
thing.
Instead, here we go quite brutally this way. So send an interested message. The message ID is 2. The payload for this is a empty body. So now we have to create let mutable. No, it's not mutable. This is called interested. Interested. I will create a vector of U8.
Hmm.
Can I create just that directly? So this is a big endian. So being big endian is 0, 0, 0, 1, and the protocol is 2. So this should be the message that we have to send.
Yes. The
Okay.
only thing, if you want it to be U8, in the first one, just put underscore U8. I think that should tell it that they are all U8. Yeah.
Oh yes, there. Okay, now we have to write to the stream. This so stream send write, not send, write. Okay, again, write all,
I think so. Yeah.
write all, and our interested message. Wait until you receive an unchoke. The message the ID for unchoke is 1. The payload for this message is empty. Okay, let
Remember
me.
to do dots await there in the yeah
Never.
without parentheses, not JavaScript.
Oops. Oops. Sorry, guys. I'm dumb. Um, Here we have to wait at this point for an unchoke message that is a 1. So we have to wait again for this. And this type, our payload type should be 1 at this point. And size should be 0. But I would like to do this again. Oh, well, it should be 0, so I don't have to do this. Okay. I have to read the size because it's part of the
Hmm.
protocol, but I can ignore it. And I can debug the size just to see if we have the second message of the protocol coming in. Okay, let's try to run it. No, wrong command. This one. Okay, the second one has size 1 because it's only the payload type,
Okay.
and the payload type is 1, like we were expecting, the unchoke. Okay, break the piece into blocks of 16K. Now we have to send a message request. The byte ID is 6.
Okay, so that's where the concept of blocks comes in, that you can have as many pieces
Yeah,
as you want, but then inside a piece, depending on the size of a piece, you have to split in 16K blocks.
yeah. But well, it tells us to split in 16K blocks, but in theory, based on the protocol, we can do what we want. Here, the protocol doesn't say to use bank code. It say all later integers sent in the protocol are 4 big endian bytes.
Where does it say we have to use bank code?
I was expecting to have to use bank code, but we are
No, I think
in
at this point it's
yeah,
just a binary protocol.
yeah. So we have to send the index, the begin, and the length. So just to simulate this, let's forge a message. Obviously, we will have to do this with a loop, not manually, but this is a request. So the size we compute it. Then the message is 6. The 0 index based, I want to get the piece number 0. So I want to get it from the beginning of 0.
From the beginning of time.
Yeah. And then 16 to 54 by 16, 110 to 410. Let's do something simpler. Let's take 56 bytes,
Hmm.
256 bytes. And all of this message is 4, 4, 4, 12, and is 13 in length. So all of this is of length 13, if I'm not wrong. Now, if we send this,
I like how you're doing all of this very manually.
okay, we send this. Wait for a piece message for each block that you have requested. Now we have to read. We request only one block, so we expect back only one block, right?
I think
So
so, yeah.
the message is 7, so our payload type here will be 7, I hope so. And then the payload for this message consists also of 4 of read the index, the begin, and the block that we know the size. Okay, so let's have a buffer. Let mutable buffer equal to u8 256 u8 because we asked 256
Hmm.
stuff there. It's not happy because okay, I have to do 0 underline u8 appear now. I have to read the index, so let index equal to my stream dot read u32 dot await. This time I try to remember it. Don't scold me, Luciano.
Yes, good job.
Then begin, we send it, but those can come in different order. So it's telling us again what is this message about.
So the
Then
different pieces can come in random orders. Is that what it's saying?
I come back in random order, yeah, I suppose so.
Okay, that's why you have the index.
Yeah, for this reason you have the index. Read all. Read exact. Let's try to see if read exact this time works. Otherwise, we have to do the horrible loop, reading one byte at
Mm.
a time and writing it back, like we did, like we did here to read the byte.
Actually, I wonder because when we do read exact or whatever, we are passing a string slice. If you could index it.
Find a mutable. Ah, okay, you have to pass a mutable reference here. Okay. Okay. Here, what we are doing is we have the request, we send the request, then we expect to read back a packet. The
Hmm.
packet will be made of a size, a payload ID, and here we know that it will be 7, but in theory here we should switch and branch based on the type of the
Hmm.
payload type. We allocate 256 bytes because we asked 256 bytes, if I'm not wrong. If we are wrong, we will find out. We read the index, we read the begin, and we read the buffer itself. Let's see what it happens.
Ooh, nice.
Okay, let me scroll. Okay, this is the first the bit field. Then there is the unchoke. Then there is a message of 265 bytes.
Hmm.
265 because it's 256 that we sent plus 4 plus 4.
Yes.
Yeah, plus 1 because there is also the payload type. 1 plus 4 plus 4 plus 256 because we asked 256. And then there is the file, the content of that piece
Hmm.
of this block. And we can ask, here it's suggested to ask 16K blocks. In theory, we can ask blocks as big as we want. I mean, here we just ask a block of 256 bytes starting from index 0, and then we got one back that goes in index 0. In theory, here up here we have a buffer for the piece made of. We should write in this vector starting from begin for 256 bytes, we should write in this one and
Yes.
loop through this to get all the blocks of the file.
Yes.
Do you want to do that very brutally, or
Let's do it very brutally. I wonder if when you do read exact, if you can already pass the range and read already inside that vector at the right place.
you mean inside this vector with the capacity?
Because
Ah,
that's
you
going to
mean
be our final.
yeah? No, sorry, this vector with the capacity. Is this vector already made of those bytes, or do I have to insert into it to really have
I
it?
think
Because
it
the capacity,
initializes with the default, which is going to be 0 or not.
but
No,
it's an
no,
empty
no, no,
vector
no.
at the beginning. It's
No,
an
you're
empty
right.
vector.
It's an empty vector. Yes.
I want a full of zeros. There is any vector zeros? I mean, in MapPy there is. In NumPy there is, but
Good question. There might be
means
dot fill after you create it.
after I create it. Okay, let's go here. Dot fill. Oh, you have to call it.
Does it return? Maybe you need to call it separately.
I also have to make this mutable. Okay. At this point, is not unused anymore. Okay, you are telling what if we read directly inside our begin plus size minus 4 minus 4 minus 1. That is in total 7, 9. Okay.
Why
Maybe I
doesn't
have
lag?
to add the parentheses. No. The type cannot be indexed by a range. Slice is not implemented for range or user to it is required.
Right.
So
I
can
was hoping you could do that, and that's maybe why there is that other library called bytes that I think it's already included. that does a bunch of extra things. Probably also this one.
Hmm. But, well, we can read in our buffer and then copy the buffer
Yeah,
into
for
this.
now, let's just do it manually. Next time, we'll see how to refine it.
So here we copied into our buffer. Now we have to say that this is equal to our buffer, to all
Can we
our
do
buffer.
that?
No, doesn't seem happy about it. Again,
You can
cannot.
probably do some kind of copy. Is there, if you do buffer dot, is there like copy into or something? Copy from slice. Copy within. Okay, this might be promising.
Now another part of itself, so you can copy inside itself.
And copy from slice. What was it? The other one you.
Ignored. Okay, so we have to call this on copy from slice buffer. I have to pass a
But
reference.
then
But yeah, but starting from where?
exactly, yeah. Not
I
very
want to start
promising.
from begin, not from any place in the universe.
We could do it manually with a for loop, but it's just annoying.
Yeah, again, we can do anything with a for loop. For our index in begin until to up to uh, today reactivated snooze, stay down, stay put. A plus 9 plus no, sorry, plus size minus 9 for this index. But well, again, I'm stupid. That's fine. For index in that 0 at underline size. At this point is not underline size because we are using it. And our index say that this buffer of idx is equal to buffer of idx. And it's not happy, cannot be indexed as u32. What it was from us. Because it wants a u size as size as u size. Okay, at this point, this is a manual copy. There should be a better way of doing this. And
Yes.
also, our buffer is 256 bytes. 256 by 256. Okay. Now we are going to make the buffer larger. So we are required, and also this number should be, this is the size, and this instead is the begin. This is we have to have manual with this. Okay, now let's take let's take 64K instead of 16K because it's just easier to write the number here. Size was the last one of the payload, right?
Not sure. I got lost there.
Oops, sorry. Clicked on the wrong stuff. Index begin length. Yes. Index begin length. Copy that one. We're not going to debug everything. This was working, so we can remove it. Okay, I'm wrong. This is the begin plus the index size is not happy because okay, and the index what is the index in the answer? Which piece are we? Okay, we don't care about the index because we are just downloading one piece at this point.
Okay.
So we don't care which one. We are getting the one that was asked. Now we have to loop this for blocks, block ID in from 0 to the length of the file. Well, how do you do steps in Rust? If you want
Well,
to do from 1 to 10 step by 3.
oh, good point. You could do with an iterator. You could
Nothing
probably do
simple.
dot iter
Because they
dot.
want to go from 0 to the length, but in steps of 65k, 64k.
Yes. Good point. I don't know if the range allows us to do that.
Step by. Dot
That might work.
step by. So this is the begin at this point.
But considering that you might not receive things in order, is this gonna work?
Yes, because in our case, we are waiting for a response before sending another request. We are not doing the 5 concurrent requests. We are
Okay.
requesting a bit, waiting for it, requesting another bit, waiting for it. We are doing the stupid way. But
Okay.
even writing all of this is already the stupid way.
Fair enough.
Okay, now we have to request the piece index that is going to be the first block of 4 bytes. We know, so we know at the no, don't do that. Okay, we know that we only have 3 pieces. But in theory, this is the piece modulo 256. This is the piece modulo. We have to split that number on those 4 bytes. For now, this is fine. Now, instead, we have to split the begin on these 4 bytes. There is a way in Rust to do so, to replace inside an array.
That's what I was trying to find.
Otherwise, I do the math. I'm not scared of that.
But yeah, basically you want to write in a specific slice, right?
Yeah, but the integer division in well, those are integers, so it will do the integers division.
Yes, it should.
It's not like Python that you should have a different operator because it's stupid. This is incredibly ugly. Don't try this at home. As U8. I have to put as U8 everywhere, I think. As U8, as U8, as U8, as U8. Okay, so this is the begin, this is the size. Let's check again. Index begin length. Okay, index begin length. Now we have to send the request, and we have to take all of this. Nice.
You lost an L.
Yeah, I lost an L in the process. We debug the size and we debug the payload. We read into the buffer, the exat. we can have a problem with the last bit, with the last block, because the last block not
Can be
be
smaller. Yeah.
can be smaller. How do we do that?
I think we need to check if it's the last one and do the difference between the remaining. Well,
Yeah, but
take the minimum between
we
the
don't
remaining.
have a read function that can read us. We don't have a read function that is reading us an exact number of bytes
Unless we create a buffer for it, right?
of that size. Yeah, but that
Yeah.
is incredibly annoying. Or we have to do the loop like here, the for loop that reads 1 byte at a time.
Yep. We could probably generalize that in a function, like read n bytes or something.
Yeah, that is, but it's annoying. Why there should not be?
I'm sure that there is. I guess we're not just finding the right way.
Yeah, I was hoping so. Because this will hang up in the last piece. Do we want to try and see it hanging up in the last block?
Will hang up or will explode?
Let's see. At the moment, is complaining that I can remove a mutable. Kind inspected end of file. Well, we arrived to 2, 1, that is the unchoke. Then after the unchoke, we send out. After the unchoke, we send a request, and is complaining kind unexpected end of file. Because what was this one? Line 13.6. I want the piece ID, that one. Beginning at here, of size this. Write my request. Okay, let's add the bug with the request sent. Request sent. Let's see if we arrive there. Okay, we sent the request, but then we did something wrong and we upset the TCP connection because the TCP connection closed after our request. So our request is wrong somehow.
Hmm.
Okay.
So you think it's being is hanging up on the other side?
I think the other side closed the door because we are stupid. The other side see that our request is malformed. This is dropping the TCP connection. Begin 0. Okay, we start at 0. So with begin 0, all of these should be zeros. That was exactly what we did before. What we didn't do before was making 64K. This one. So let's try to do. Let's try to do 16Ks like they were telling us. Okay,
Okay.
this is a 64, it's not a 65. Roberto, please. So let's try to do 60K. So again, I want the first bit of it 13. Is this 13? Is the length of the 4 plus 4 plus 4 plus 1. Yeah. Then is 6 because I wanted. The piece number 0. The begin is 0 because we start at 0. And the length is 60K. We made a buffer of 50K. This should hang up at this point in the last, not the first. Okay, request sent, size 7, paid, index out of bound, length is 0, but the index is 0. Okay, this is something that we did wrong in 364. Piece buffer. Fill. Okay, it was not filled for real.
Mm, okay. So what you can do, I think you can do an array
Can
of
I
the
use this?
size that you want, and then yeah, yeah, that.
Can I do this?
I think so. Yeah,
So now is a vector of u. At this point, even filling it is not
is not
important.
needed. No, it's already gonna be filled.
Okay, let's do this instead to have the array allocated in the heap. Okay, now index out of bound. The length is, but the index is 60k
Okay, we
out of
just
bound.
which line
From
was that?
0 to the sides. Okay, the size. Ah, yeah, sorry, to 0 to the size minus 9, because we have to remove the payload type, the index, and the begin. We were just going too long.
Okay,
Request send sides out. So the total. Okay, what is the length of our? Let's debug this. DBG, a reference to this guy. 32k is our length, and is only doing one loop. Ah, because okay, I forgot to update the step by. Forgot to update the step by. Chulu chulu.
okay, yeah.
Okay, back to where is it? Let me remove this. Okay, the file is exactly 32k. The piece, not the file. The file is different, but this piece
Right.
is exactly 32k.
So it's probably only the last piece that can be smaller.
Yeah, this is exactly 32k. So I'm reading 16k. I'm reading 16k. And our buffer is correct. Now, if I
Okay,
ask the piece number 1 is working, I ask the piece number 2 and off, because
okay.
we are trying to read more than there is to read,
Mm-hmm.
because the last one is not 32k.
Yes.
If we add back our, where is it? If we add back the debug that I removed from here, dbg to reference to this.
So we know the length of the piece. That should be
Yeah,
16 or
the last,
32.
no, again.
Yeah, that's the length of every piece, but then there should be a total length of the entire file somewhere.
Ah, yeah, we have the piece length, the number of pieces, and the
Length.
total length of the file.
Yep.
Okay. Yeah, yeah. And also we need to know when is the last, when we are asking the last one. Okay, let's go with the epipath for now of the.
Yeah, we have Jopna. I hope I'm pronouncing the name correctly. Hello, Jopna. Is suggesting they are suggesting how to keep track of all the numbers. Could it be easier to name them as constant variables? Pretty much yes. We are trying a very dumb and raw implementation first. Then we want to refactor this in a more, I guess, protocol-based
Proper
approach. Yeah,
way.
where we define proper struct with all enums for the different message types and hopefully generalize all of this stuff. I hope that makes sense.
Okay, here was trying to get the size, but why didn't log it, the size? Oh, because we request write all and then read, and the connection dropped. Okay, because here we asked again 60k, but
Hmm.
16k were not available. So it just yeah, it just cried in a corner.
Yes.
Yeah, this is tricky because now we have to take the total length, having the number of pieces, and compute, if we are asking the last piece, compute the proper size that we have to ask for the last one. I would do this next time after we refactor it,
Yes. Yeah, I agree.
because
I think we might have to use one of those bytes crates because I think they will make our life a little bit easier to do all of this
yeah,
dynamic stuff.
yeah, because if we ask 0, it works. Now in memory we have, and we could output it to this file for the
Hmm.
piece number 0. But when we ask the number 2, that is the last one of the 3, and we know we have 3 because of this number, and also because we have a 3 in the vector that comes back from info.
Yeah, I'm
Uh,
curious what file are we gonna download? I'm also curious to see that.
we'll see. But well, anyway, we arrive at the point that all the we understood the protocol, at least is working. We just have to make the request for the last bit that is not recording. I want 16K, but we have to get the right amount of bytes based on the leftovers, and we have to compute it.
Hmm.
We have to compute it maybe here when we allocate this, because the piece length will be not the one in meta info, but will be something different. So here we have to compute current piece length equal to this if the ID is less than the last one. Otherwise is and then modifying this here, 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 and we have to modify those 2 bytes to be the leftovers when we are in the last step. Okay, we know what to do. Do we want to wrap
Yes.
up here for today
Yes.
with something more or less working?
Let's wrap it up.
Yeah,
Yeah,
yeah, yeah.
this was an interesting one for sure. And yeah, let's just call it a day. Basically, the usual info is that if you're following this on YouTube, you're probably watching the recording. So be aware that we stream on Twitch more or less every Monday afternoon, 6 p.m. GMT. When I say more or less, is because we are not always super consistent. We have work after all. So sometimes we cannot make it. But yeah, we try our best. And what else? We're going to be continuing doing this CodeCrafter exercise. So I'm going to drop the affiliate link again if you want to have a 40% discount, if you like CodeCrafter and want to try all the other exercises. And yeah, our Twitch is in the description of the channel. And if you're following on Twitch, our YouTube with all the previous recording is on the description of Twitch. And we have pretty much everywhere the links to our repositories. If you want to double check the code, feel free to send PR or whatever if you want to suggest better approaches for doing this stuff. So that's everything I have. And I think we'll see you in the next one. Bye.
Bye.